Assume that the paired data came from a population that is normally distributed. Use a 0.05 significance level to find D bar, S sub D, the t-test statistic, and the critical values to test the claim that mu sub D equals 0. So what we're hypothesizing here is that the population difference is 0. Population mean difference. Now, the thing we want to focus on is that we're told that this is paired data. And so when that's the case, what we're going to be looking at is differences. Differences between these individual pairs, and then the average of the differences. So like if we were to do this, x sub I minus y sub I. Here we'd have minus 2. Here we'd have positive 2, minus 1, minus 2, 2, minus 2, 5, minus 5. And then we'd find these are the differences right here. This row that we just calculated are the individual differences. And then we could find the average of those differences. We're going to use StatCrunch to do all of this. So we'll hit StatCrunch. And what we're going to do is type these values into variable 1 and variable 2. As a matter of fact, I'm going to go ahead and name the first column X and the second column Y so that I keep them straight. So the X values are 7, 7, 4, 8, 16, 3, 14, and 10. The Y values are 9.0, 5.0, 5.0, 10.0, 14.0, 5.0, 9.0, and 5.0. And we see that StatCrunch doesn't care about the point zeros. What we do have to make sure that we do, though, is keep these paired data values together. It is important that this 7 and this 9 go together, and this 7 and this 5 go together, and this 4 and this 5, because they are paired data. Now I'm going to click Stat, T-Statistics, Paired. Sample 1 is in my column X. Sample 2 is in my column Y. I'm going to hit Next. This is asking me to conduct a hypothesis test at a 0.05 level of significance. And I'm testing that the population mean difference is 0. So I'm going to keep the hypothesis test radio button selected, and then my null hypothesis is that the difference is 0, and my alternative hypothesis is not equal to. I'll click Calculate. Now a lot of what I need is here in this box. D bar was the first thing I was looking for, and that is 0.875, as we can see in this box. So we'll type that in here. Check our answer. The next question is to find the standard deviation of the differences. And we'll look at our output box here. And that actually isn't given to us. We have the standard error, but not the standard deviation of the differences. So what I'm going to do is I'm going to go to Data. And what I'm going to do is I'm going to transform some of this data. I'm going to do this by selecting column Y and selecting column X. And in the expression box, I'm going to type X minus Y and hit Compute. Now what this did was it added a new column to the table. And this column is made up of these differences here. Minus 2, 2, minus 1, minus 2, 2, on down. Minus 2, 2, minus 1, minus 2, 2, minus 2, 5, and 5. So now I'm going to hit Stat, Summary Statistics, Columns, X minus Y, Calculate, and now I have the standard deviation there. It's 3.04431. The problem asks me to round that value to 3 decimal places. So I'm going to type 3.044. Now I'm supposed to find the T-statistic. Well, that was in the first output box that we found when we did the paired T-statistics. And that is 0.813 when we round to 3 decimal places as specified in the problem. Check the answer. Now we're supposed to find T sub alpha over 2, or our critical value. So we look back at this output box and see that our number of degrees of freedom is 7 in this paired T-statistics test. So I'm going to go back to StatCrunch, and I'm going to click Stat, Calculators, T. And then I'm going to look back at the alpha level for this problem, which we were told was 0.05. So my number of degrees of freedom is 7. If I have a two-tailed test, like we're doing here, mu sub d equal to 0, mu sub d not equal to 0 in the alternative hypothesis, and I'm splitting 0.05 out into each tail, then I'm going to have 0.025 in each tail. In the left tail, 0.025, and in the right tail. So this is going to give me a t-value of 2.365 when I round to 3 decimal places. Plus or minus 2.365.